I'd like to do several problems with you from Assignment 6, Unit 5, Assignment 6, or Worksheet 6. It's factoring is not an easy thing. Some of this is going to be coming back to you from Algebra 1, but here the goal is to completely factor by finding common factors in quadratic expressions. Now that may mean a greatest common factor. It doesn't always mean that, but it can mean that, and it will in certain situations. So let's get to, I've circled several questions on the worksheet that I want to do, and I've written them down here. So let's begin with question 3. And I really hope that I copy them down right. When we're factoring, we always look for a GCF first. Look for GCF first. If you don't find a GCF, then you start the factoring process, and since there's no GCF here, I'm immediately going to break this apart into two binomials. Now remember, this is what we call a trinomial because it has 3 terms. But I'm actually going to break this into 2 binomials that are being multiplied together. Factoring is a fancy word for dividing. We're breaking it up into 2 parts that multiply together to give us the bigger part. So how do I get the first 2? Remember, this kind of goes, this is almost saying reverse FOIL. Now there are several ways to do factoring. You might have a favorite way to do it, and if you like a certain way, I have no problem with you doing it as long as you're capable of doing it. Some people like to use the box. I don't typically use the box for factoring unless I can't figure any other way to do it. But I'm going to get x squared by multiplying x times x. Now that would be what you call the firsts, right? Firsts, outsides, insides, lasts. Then we need 2 numbers that will multiply together to give us -8. Well, obviously that must mean that one of them is positive and one of them is negative, because that's the only way you get -8. And then what I need to do is I need to start thinking about the factors of 8. 8 times 1, 4 times 2. I'm looking for a set whose difference is 7. Difference is 7. And in this case, you're right, 8 times 1. So I want the 8 there and the 1 there. Does it matter where they go? Sure it does. So I double check. I've got 8x from these 2 and -1x from these 2, and they add up to +7x. Had I switched the 8 and the 1, I would have gotten -7x, which would have been incorrect. So this is the complete factorization of this particular trinomial. Well, what about question 12? Question 12, no GCF. Okay, that's always what I check for first. So now I can start breaking it apart. X, X, let's see. Now this time I need two things that multiply together to give me 100, and they must multiply together to give me a +100. Well, that means you're either going to have 2 positive numbers or 2 negative numbers to get a positive multiplication of 100. And what is it going to be? They're both going to be negative. Because the only way the outsides and insides are going to add up to a -29x is if the 2 numbers are negative. So let's say this was, so then you start thinking about your 100 times 1 and 50 times 2 and 25 times 4 and what other things we got here? 10 times 10 to go into 100. And you can see this one right here has a sum of 29. A sum of 29. Which means that's how we're going to get. Now it doesn't matter whether that one's the 4 and that one's the 25 or switch, no, because it doesn't, they both have the same sign. And you can check to verify that about question 15? That doesn't even look like a trinomial. Well, something cool is going on here. First of all, is there a GCF? Yes, there's a GCF. And that's what you need to take care of first. So what's the common factor? They both have an x. So I'm going to pull that out. Now what you're doing, folks, is you are dividing each one of these terms, which would make that one a 3x and this one a minus 2. If you were to distribute the x back inside, you would go right back to the beginning. We obviously do not need to do that. Now, there is nothing else I can do to factor that. I have seen questions on tests before where the only thing you could do is pull out a GCF, and kids will sit there and sit there and sit there and try to come up with something else. The whole time they're burning up a lot of time on the test instead of just pulling out the common factor. Okay, on this next one, is there a GCF? No, there's not a GCF. Okay? But it's not a trinomial like the other ones were. However, you could write it as x squared plus 0x minus 81. Actually, it would be a minus 0x. I guess it really wouldn't matter, would it? At all. Because it's 0. Yeah, that was a really dumb thing to say. Sorry, children, for causing such confusion. Now, I need x times x, obviously, but then I need two things that multiply together to give me negative 81 that add up to 0. That's why that middle term is gone. So 81 and 1, well, they don't have a difference of 0, do they? What about 9 and 9? Yep, that's it right there. So one of them has to be a positive and one of them has to be a negative. And if you double check the insides and the outsides, you'll see that they disappear. So the linear term is gone. This is called a difference of perfect squares. Okay? Now, a difference of perfect squares is something that you can easily factor, right? Because what's the square root of x squared? X. What's the square root of 81? 9. Well, that's what the two parts are in each one of them. If you will glance at your worksheet and look at, here's a difference of perfect squares. Here's a difference of perfect squares. You just need to take the square root of each of these and then put a 1 and a positive 1 in it, a positive and a negative in it. Positive and a negative. You just need to take the square roots of each of these. They don't have any GCFs, and they are each perfect squares that are being subtracted. Okay, same thing with 48. I don't see a GCF on number 48, so you can go straight to square root, one's a plus and one's a minus. Okay, so difference of perfect squares, that's a special case. Now, question 30, is there a GCF? No GCF. So, I'm going to go straight to breaking it apart. I've got x times x, that's how I get x squared. Now, this one says they need to multiply together to give me 40. So they're either both going to be pluses or both going to be minuses. And the answer is they're both going to be pluses. But we need factors of 40. So 40 and 1, 20 and 2, let's see, 8 and 5, 10 and 4. I need something whose sum, right, whose sum is 13. Well, that's got to be this winning combination right here. Doesn't matter where you put them because they're both the same sign. So there we have it, plus our insides and outsides give us 13x. Okay, so those are ones from your Algebra 1 days. We get to a couple that are a little bit more difficult. Questions 53 and 72. Now I'm going to show you something that kind of looks like a magic trick. I want you to pay close attention because you're going to have to practice this. Okay? Now, what happens if the leading coefficient is not a 1 and you can't pull out any GCFs, right? No GCFs. Okay, well, so what I'm going to do is, it's almost going to look like a magic trick. First, I'm going to multiply that, so it's almost like I picked the 4 up and got rid of it. So, you might be wondering, well, how in the world can you do that? And I multiplied the 4 times the end value of negative 15, I got negative 60. So, this now looks like something we can factor. Okay, we can x times x. I need factors of 60 whose difference is negative 4. Factors of 60 whose difference is negative 4. Well, there you go, 6 and 10, right? So, and we want a negative 10 and a positive 6 so that the insides and the outsides will give us negative 4x. Well, here's the second part of my magic trick. The 4 that disappeared at the beginning is now going to return in front of both of the x's. Now, look for any GCFs to eliminate. We're actually going to pull a GCF out of any term that you see here and get rid of it. This shares a 2. So I'm going to pull a 2 out of here, and I'm actually just going to throw it away. So if I divide this by 2, it looks like 2x minus 5. This shares a 2 also. I'm going to pull it out and throw it away. 2x plus 3. And there is your factorization of the original. If you go through and FOIL what you have here in this right here, you would get back to the beginning. Now, if I don't do it this way, I'm going to take a long time to some teachers have their students guess and check and guess and check. That's what my teacher did, and it took forever, and I got really mad because it took forever for me to do that. So let's try this again. We're going to take the 12. First of all, no GCFs. Always got to make sure there's not a GCF hiding. There's nothing in common, so now I can take that and multiply times the end, and so that becomes a minus 60. Wow, this looks very similar to that one. I didn't even realize it was going to happen that way. So I factor it the way I did before, x and x, and then I need factors of 60 whose difference is 4. Wow, I might actually have to do a different problem just to kind of show you something different. And now the 12 comes, well, no, maybe it'll be okay. Now the 12 comes back in, right? 12x plus 10, 12x minus 6. And now I look for GCFs to get rid of. I see a GCF in there of 2 that I can pull out. If I pull out a 2, I get 6x plus 5. I look in here and I see a 6. So I'm going to pull out a 6, 2x minus 1. And so here is your factorization of that. This is something you're going to have to practice. You might even have to watch this video over a few more times just to make sure you understand what we did in 53 and 72. The circle problems, the other circle problems on the worksheet that are not in the right column that you need to work on, and those would be, since you probably don't have them, I need you to do, so we did several problems here. We did 3, 12, 15, 18, 30, 53, and 72. But I also need you to do 61, 71, 73, 74, 75, and the entire right column. Okay, so do the whole right column, and then there's a couple more problems here. We did one of them there, so there's 4 more there. So the whole right column.